What are most common oversights in a pre-renovation structural assessment? And can you share a real-life case where the lack of proper evaluation caused significant delays or structural failures?
So the biggest mistake that people make when it comes to foundation repairs anyway, is that the first thing they do is they Google foundation repairs, right? Well, guess who comes up? The guys that spend all the money on advertising, the foundation repair companies. They spend a ton, and I know because I used to be one of them. And they're going to come up. They're easy to find. But the problem is they're going to send out a commissioned salesperson who is 100% commission.
Have you ever seen a renovation that completely backfired? You're not alone. Studies show that over 50% of home renovation projects run into unexpected structural issues, many of which are tied to foundation and load-bearing challenges. In today's episode, Alex and I will be talking with Bob Brown, author and co-founder of SpatialVision, about the top reasons renovation projects encounter structural and foundation-related issues. From poor initial assessments to overloaded framing systems and water mismanagement, Bob breaks down real-world cases of renovation disasters and how they could have been avoided. If you're a structural engineer, contractor, or homeowner planning a renovation, you won't want to miss Bob's insights on what goes wrong, why it happens, and how to ensure your next project maintains structural integrity and long-term stability from the foundation up. I'm your co-host, Matt Picardle.
And I am your co-host, Alex Dano, and this is the Structural Engineering Channel.
Bob, thanks so much for joining us. Can you tell us a little bit about yourself, your business, and what inspired you to focus on renovation projects?
So I graduated from Arizona State University a long time ago in architecture and in finance. And I worked my way through college doing concrete repairs. And so I basically, over the years, just kept the company and added kind of more unique things to it, mud jacking, and eventually worked my way into foundation repair. And so I sold both of those companies. At the time, I had a foundation repair company and a forensic engineering company. I sold both about 2.5 years ago. And and I've written a book, and I've got some software and a few little projects here and there. I'm not really trying to kill the world in terms of making a ton of money, because I got plenty of money when I sold, more than I'll ever need. But what I want to try to do is educate the public, try to make the world a little better place.
Yeah, that's awesome. It seems like some of the stuff that we're going to be talking about can really help the homeowners. And I know when homeowners are first starting to get into repairs or whatnot, a lot of them don't know because it's probably their first construction project or something. So yeah, we'll talk about that.
Yeah, and it just sounds like you've kind of had a long career, run into quite a different things. So what are most common oversights in a pre-renovation structural assessment? And can you share a real-life case where the lack of proper evaluation caused significant delays or structural failures?
Well, that's a loaded question. I could spend all day just answering that one question. So the biggest mistake that people make when it comes to foundation repairs anyway, is that the first thing they do is they Google foundation repairs, right? Well, guess who comes up? The guys that spend all the money on advertising, the foundation repair companies. They spend a ton, and I know because I used to be one of them. And they're going to come up. They're easy to find. But the problem is they're going to send out a commissioned salesperson who is 100% commission, no salary most of the time. That's what it is. And these guys make a lot of money. They make somewhere between $100,000 and $300,000 a year. And if they don't make at least $100,000, they kick them to the curb. Okay. So when these guys come out and do an evaluation, it's really just a sales pitch dressed up to look like an evaluation. So the big problem is that, they have questions. They want to know, okay, gee, is this really bad? Is it going to continue to get worse? What happens if I do nothing? Is my house structurally deficient? They're getting answers from somebody who wants to sell them something. So how do you think they're going to frame it? they're not going to be blatant. Most of them don't, say, "Oh, your house is falling down," because they're not, that's a little obvious, right? But they dance around it and they make people feel insecure in their home and want them to like spend $60,000 making themselves feel secure and safe and and good for life and all these other problems. And the fact of the matter is that the analysis is totally lacking. It's not scientific. It doesn't use engineering principles. The gauges of severity are not established engineering norms. They're, some made up BS about, gee, on a scale of 1 to 10, I think you're like an 8.5 because my kids need braces, kind of thing. So what was the second part of your question?
Oh, it was, can you share a real life case where lack of
Oh,
proper evaluation kind of came back and bit somebody?
gosh, I got a million of them, but I can, I got one that really displays vividly. So I remember a lady up in the mountain part of Arizona had a stem wall that never got grouted. The rebar was in it, but it never got grouted. And so it had started to move away from the foundation. And it was just, there was like 2 inches just barely holding up. Well, foundation repair salesman came out and said, "Oh yeah, if we underpin that footing, it'll rotate that thing back into place." She's like, "Oh, cool. All right." Well, they underpinned it, didn't rotate at all. And when they were all done, they want to get paid. She's like, hey, the reason why I called you, the problem never got solved. Well, they pulled permits for that project and they had an engineer seal the design. But guess what? I talked to that engineer and I'm like, hey, you kind of missed this, like, well, why didn't you address this? And he's like, well, they didn't tell me anything about that. This is first I've heard about that part of it, and that's the problem, the salesman is telling the customer, oh, don't worry. The salesman is going to check everything and make sure it's all right when we pull permits. And that's a bald-faced lie. And the engineers don't even know that that's the salesperson is making those claims. They don't understand that. They can't evaluate everything because they didn't gather the data, right? Nobody under their direct control gathered the data. So the fact of the matter is, it's done by a salesman from a different company. And the only thing the engineer is doing is a spacing calculation, WL squared over 8. It's not that hard. I mean, the spacing calculation is probably the easiest part of a foundation repair. And with standard footings and stems with rebar, it's going to be somewhere between 6 and 8 feet, depending on if it's block or concrete, or if there's snow loads, or if there's rebar in the concrete, it might be a little less, right? There's no rebar. And so those kinds of things are the things that don't get looked at. So what I mean by that is you could have piers on the wrong side of the house. You could have piers too many, too little. You might not even need piers at all. And the permit process doesn't correct for any of that. And the engineer doesn't check for any of that because he doesn't review any of those findings. He doesn't check what the problem is. He doesn't check what the solution is. All he's doing is a spacing calculation. And this example that I was telling you about is a perfect illustration of that. They just calculate the spacing, stamp it onto the piers that the salesman designs for the plan, and send it in for permits. And the permit checker, they don't know anything. They're like, oh, the spacing looks good. Okay, you got your permit. And meanwhile, the homeowner's problems go completely unaddressed.
Yeah, it seems like there's that big disconnect between what's actually the infield conditions and what the actual problem is, which takes some, forensic engineering. But if a salesperson is doing the engineering, it's kind of like, wait, where's the forensics engineer?
Exactly.
There's that huge disconnect.
And I don't know why the world thinks this is okay. I mean, we have sales guys that are practicing engineering without a license. They're making modifications to the structural components of a house. They're analyzing soil conditions, which is a geotechnical, endeavor. and determining that, oh, it's going to continue to move, and they don't know anything about the soil. All of these functions are engineering functions, and they're doing without a license.
Yeah, it's like from I think a big reason there for you doing this too is because a lot of homeowners don't know. They just they
Yep.
Google it. They call the first person there, the foundation design experts from Google, and I mean, it's got to be top of the
Exactly.
ranks for Google, right? There's some there's a
And
reason
that's
why
the
they're on
problem.
top.
Engineers are not good at marketing, right? I mean, let's
Yeah,
face it, we all know the truth. And so I've made it my job to try to help engineers do a little better job, to help them with their marketing, help them with their analysis, help them with some best practices to keep the costs down, right? Because let's face it. I mean, if you're an engineer and you're gonna go out and do an evaluation to do it right, you're gonna charge $3,000. Well, the foundation repair companies are doing it for free. I mean, how does free compete with $3,000? You know, hey, the foundation repair might cost 10,000. That's a third of it. That doesn't even make any sense, right?
yeah.
But there's ways
Mhm.
to do it. There's ways to keep it cheap by having observers gather the data, certified observers and trained, so that the engineer doesn't have to go to the site. And that's part of what my software can do, is help engineers with those kinds of things, to keep the cost down. If the engineers don't have to go out to the site, they can charge maybe, a grand or a little over or under, as long as they don't have to go to the site. And as long as they know that whoever's gathering the data is going to not miss anything important, right? That's the key. And it's kind of hard for engineers to see that right now. They're like, oh man, I don't feel comfortable with that idea, right? But it can be done, and it's being done. We could talk more about that, now or later or whatever. But
Yeah, it's like you were mentioning too, we're not the best marketers. Like if you ask maybe a typical
right,
engineering firm, hey, how do you get do you know how to get top ranks on Google? And it's probably not because of how good of an engineer you are. it's it's like
no,
there's
I
the
mean, they don't even know
marketing.
that there's a Google business page that you get for free, right? That most engineers don't even know that.
Yeah, so that's kind of like the marketing experts know how to do that, but they're not engineers. So there's that disconnect that you're trying to
Right,
solve. So I think
right,
it's good. And I did want to, because you mentioned soil, and I know soil, at least for engineers, I know that's a big part of it, but maybe common folk don't know too much about it. From your experience, how does the existing foundation underlying soils, impact the success of a project, and what can the engineer do when
right.
addressing some of those concerns?
Well, I had a friend that worked for Skanska, big road contractor, tell me once that, yeah, all roads are dirt roads. And I'm like, what? He's like, yeah, it doesn't matter whether you paint them with asphalt or paint them with concrete; they're all dirt. And I thought, that's pretty cool. I like that. In essence, the house is the same way. It's sitting on the dirt, and the foundation is going to be affected by the soil. So that's, whenever you have foundation problems, almost always it's because of soil issues, right? And a lot of people think the soil is super simple when it's not. I mean, it's deposited in layers, and each of those layers have different densities and different affinities to water, different mineral contents. And the layers are not always even. They're fat on one side, and they get small and disappear, and maybe reappear at another level, and rocks and all kinds of. And if you have clay, those soils are going to expand when they get wet, and if you have like maybe silts or sands, they're going to contract. And so you got a lot of things going on all at the same time, and water is coming down at different levels, doing different things to each of those layers. It can be very complex, and geotechnical engineers have a good handle on that, right? They know how the geology was deposited in an area. They do a lot of borings all the time, and so they have a better handle on being able to opine about what's going to happen, and is the house going to continue to move, or is it not going to continue to move, right? I mean, that's the big question that everybody wants to know, and you really have to know the soil to know the answer to that.
Yeah, that's why there's like that whole profession too for geotech, where I know a lot of the times we do rely on the expertise of the geotechs for any of those, because even as engineers, we're not that's not our expertise. There's another expertise for that.
Right.
Yeah, and that's another thing that's missed a lot oftentimes when the foundation repair sales guy comes out for everything. They don't consult a geotech, so they've just kind of taken a shot in the dark with what they've done in the past. And if you bring a structural engineer, geotechnical engineer come in and study the problem, you can probably get away with a lot less work out in the actual site if you do a little bit more homework up front. And everybody sees the ground, they go, "Oh, you can put anything you want on the ground. The ground's the world, right? It's as strong as it needs to be." But I think the more you know and the more you study, you realize that, oh, yeah, sand behaves a lot different than clay. And there's kind of a limit to what you can actually support on any given site. So if you were to look at the skyline of Manhattan, you can kind of tell what the soil profiles are just by how tall of a building shows up in each area. Like the taller buildings are on rock, the shorter buildings are on softer soils. So kind of tying into that, what risk does adding weight like a second story or heavy finishes pose to an existing structure, and how can structural engineers properly assess whether the framing and foundation can support the loads once they're done with the soils engineer?
Yeah, well, it's pretty much just exactly what you said. If you're going to add more weight to it, maybe even solar panels, you want to make sure that that the footings are designed to be able to handle that additional weight. And again, it kind of comes down to the soil, right? The footings were designed for a certain load with certain soils. Maybe they use the minimum bearing capacity calculation, 1,500 pounds per square foot, kind of thing. And now you put a second floor on it. Mm, now you may be looking at, double that, although that's a pretty conservative calculation. It still might not be enough because the soil might be right on the edge of holding 1,500 PSF, and now you've added all that load to it. Not going to work, you know. So yeah, and most of the time, the municipalities will probably require an engineer's seal to pull those permits. And that engineer, if he's good, he's going to realize that this could be a potential problem. So let's get some soil information.
Yeah, I can remember making that recommendation when I was a consultant, saying, "Hey, I can design this to the code minimum 1,500 PSF, but there's nothing that actually even guarantees that your soil will even make the
Right.
minimum." So if you want the most efficient, solution to your new foundation or how to add this load to the building, we should go to a soils engineer and get accurate number for what this soil can actually support. But,
Right.
above
Right.
above that, for the rest of the house, what are those associated risks with adding weight? I mean, from my experience, I know things crack, but is there anything else people should be thinking about?
Well, typically what happens when your footing starts sinking into the soil from too much overburden or something going on in the soil that wasn't anticipated, right? You it's exactly what you said. You're going to get, cracks in your sheetrock. You're going to get doors and windows out of square. You're going to get slopes in your floor. You're going to get cracks in your floor. You know, those are probably not going to be structural deficiencies. The house, it's not going to cause the house to fall down. What's going to be is a serviceability problem, right? And so, how much serviceability does the homeowner want to, put up with? Those are kind of difficult questions for engineers to anticipate and answer because there's some subjectivity to them, right? But the general guidelines are if the doors are sticky all the time, the windows don't work right, you got cracks opening and closing. If the house, is difficult to sell real estate wise, then those become serviceability problems.
And serviceability problems can be just as expensive as structural problems, sometimes even more expensive.
Yeah, foundation repair companies charge 60 grand to fix serviceability problems all the time.
Yeah, yeah, and then you spend a bunch of money on a new place, and all of a sudden the slider doesn't open. That's going to have a larger impact on you than a crack in the back corner of the footing. So I think an engineer that talks with the actual owner or whoever is looking into the issue originally and try to understand what are they looking at. And that kind of goes back to what you said before, your initial example of the stem wall that's coming out of the plumb, right? The engineer needs to be involved to establish kind of the criteria of what the project needs to accomplish, whereas the salesperson will come in and say, hey, this is what I want to do to fix your foundation, and this is what we have been doing.
Right.
But it doesn't
Right.
actually
The
cover it.
salesperson is going to be there to sell something, to earn a commission. That's just the bottom line. And I tell people all the time, hey, okay, you're going to have to spend some money. It's not going to be free. They're like, oh, and I'm like, well, okay, look at it this way. If you were really sick, if you had a serious health problem, really sick, I'm not talking about like a cold or something, right? You had a serious health problem. Well, would you pay good money to go to a doctor, or would you go to a pharmaceutical rep for free?
Yeah.
Think about it, because it's very similar to that, right?
Yeah, and addressing that root cause of the problem is really the goal for any structural repair. You understand what went wrong, and then you can fix it. If you just come in and start fixing things, probably end up right back where you started.
Right. Well, let me explain to you how people can pay for the engineering and come out ahead. So right now, what happens is you have 3 contractors that come out to a house, and one gives 15 piers over here, and one gives 12 piers over here, and one gives 25 piers all the way around. Well, the homeowner, I mean, they're not experts. How are they supposed to know the answer to that question? They don't know the answer. They're not qualified. They don't understand it. And by the way, the foundation repair companies kind of do that on purpose, because now they don't have to bid apples to apples. They can kind of engage in salesmanship, right? Oh no, our plan is the best. We're the smartest. We know what we're doing. We're smarter than engineers. They say that all the time. And then the homeowners kind of be like, well, I'm going to go with this guy. And they pick the guy that, they feel most comfortable with, which is the best salesman. Well, he's probably the least qualified of the 3. And in fact, all 3 plans could be wrong. So a better idea is to go ahead, spend the money, hire an engineer, and then the engineer will give you a plan. Put 6 piers right here. Go get a bid for 6 piers. Bid this plan out. And if anybody bids anything different, then they're going to be a non-responsive bidder. Okay. Now, foundation repair companies, they're like, well, I got to sharpen my pencil here. I'm bidding a plan from the engineer, and I'm bidding against 2 other guys. I better sharpen my pencil. Trust me, you're going to save enough money through that bidding process to pay for the engineer.
Yeah, that's a good tip. It's like, you don't just rely on the contractors to make drawings of whatever. You get an engineer, you can actually get something that has numbers to it, has some logical sense to it, and then you make the contractors, hey, you actually got to show the numbers or optimize it, or they got to hire their own engineers on why X amount of piers is needed or not needed for this. So there's some actual engineering and some logic behind it once you get an engineer.
Right.
Could you talk about some of the dangers or the damages that water intrusion and poor drainage can do, and maybe some things homeowners, strategies they could employ to make sure that those are both protected?
Great question. Okay, so when it comes to soil, water is almost always the catalyst, and it pays to know the geology of the neighborhood you're in. And the reason I say that is because it makes a big difference as to what your strategies going forward are going to be. So I'll just give you 2 examples. You're in some place like Phoenix or Tucson or anywhere dry, Nevada, Western Washington, or Eastern Washington rather, Eastern Oregon, Dakotas. You're in those dry areas. The name of the game is going to be get the water away from the house, right? Have good gutters on the house and hard pipes that hard pipe at 20 feet away. You want to get the water away from the house, because what if you don't, the water is going to dump on the edge of the eaves. It's going to go under the house. It's going to accumulate, and it's either going to cause heaving or settlement or both. Now, if you live in Houston or Louisiana or someplace like that, Florida, Western Washington, Vancouver, the name of the game is keep the moisture the same. So in Houston, I know that it's very common that they tell homeowners to put a soaker around the house with a timer and soak it once a day. Well, I'd be nuts in Phoenix, you know.
Yeah.
There's no way, right? So you need to know, you need to understand what's going on in your part of the neighborhood. But once you understand that, then the fixes are pretty simple to do, right? Gutters, drainage, soaker, managing water, right? And a lot less than doing peering. So it pays to do a little bit of research, understand it, maybe go find the local geotech in your area, go take them to lunch, have them understand what's going on with your neighborhood, or just hire them to do a plan and help you understand what needs to go on.
Yeah, the common strategies for the soil that's around your area. It seems like depending on the soil, there's some solution that most of the neighborhood should already be doing.
Right.
Yeah, and that ties in with what we were saying earlier. Just kind of, again, going back to that root cause, you're talking about wetter climates keeping the soil wet, drier climates keeping the soil dry, but more understanding that the soil moved for a reason, and you need to address the reason why it's moving, and
Right.
that'll help you fix your foundation long term.
Exactly.
That's been very, very interesting. So I have another question. What are the most common shortcuts you see in your renovation projects that compromise the structural integrity, and how can structural engineers help ensure that safety and code compliance aren't sacrificed for cost savings?
Okay. Well, one shortcut is offered by the foundation repair companies. Let me tell you what it is. They give a lifetime warranty for their repairs. And so that's supposed to make everybody feel really good, right?
Sounds good.
And
Yeah, it does.
sounds
For
good.
live?
It sounds great. But in reality, it doesn't mean much, and I'll tell you why. So the engineering products like the push piers and the helical piers and that kind of stuff, they're actually pretty good products. Okay? If installed, in the right location, installed properly, they'll probably last as long as the house. But that's not the issue. The issue is it the right location? Are they put in the right area? Let me explain that. So 5 years later, after the house, after the underpinning is done, new cracks start happening in the house, and so they call the foundation repair company and say, "Hey, come honor your warranty. Come out and So they send out one of their really experienced guys that knows all about heat because the salesman doesn't, right? Or at least he pretends he doesn't. And he says to the homeowner, "Hey, these problems are caused by heave. It says right here in our contract that piers can't stop heave, and we don't warranty for heave, So have a nice life." And so then the homeowner's like, wait. If this is heave, then didn't you kind of diagnose it wrong in the first place? And the contractor's like, well, hey, what do we know? We're just stupid contractors. We're not engineers, And that's exactly what happens. And there's a bunch of get out of jail free cards just like that in those contracts. So what's valuable to homeowners is an engineer's seal. An engineer's seal that says, I designed this plan, and I was the special inspector, and I saw it was installed properly, and I put my seal on it that they should perform long term. That's worth something, because half the time, another good example is the homeowner calls the contractor up and says, "Hey, we got more problems." And he comes out and says, "Well, yeah, you got a problem on this part of the house, and not where we put them, Great, well, that'll be another $25,000, please. Wasn't planning on that, right? So that's just two of many common problems with these lifetime warranty offers.
What about, so when that does happen, is it because you mentioned the stamp? If the homeowner wanted to sue or something, would they be suing the engineer instead of the contractor, or does everyone just gets sued?
Good question. Good question. So there's an interesting thing happening in the industry, the foundation industry right now, and that's a lot of consolidation. It's typically been a lot of mom and pops, single-owned contractors, and they're selling out to big private equity companies. Good luck suing them, right?
Yeah.
They're traded on Wall Street. They got money. And so your chances of getting anything at all any kind of satisfaction is going to be very, very tough. And so then you better be prepared, to spend $300,000-400,000 on attorney's fees and, 3 or 4 years. And unless your attorney is really good and hires the right experts, it's going to be a tough win. And the other half of it is, well, what about like the contractors boards, like the registrar of contractors, won't they come and help us? No, because what's going to happen is they're going to come out to the job site and the contractor is going to say, hey, our peers are performing great, but, we didn't design them for this. This is a design problem. And the state contracting board is going to go, we don't oversee design. We just oversee workmanship. Sorry. So then you call the engineering board, the technical board for engineers, right? For your state. Well, they're going to come out, they're going to go, well, you have no jurisdiction over contractors. And so it results in what I call the design donut hole, where nobody oversees the designs for these foundation repairs. Nobody. It could be completely bogus. Nobody checks to make sure it's the right plan.
Yeah, it seems like it kind of just goes off whatever the salesman says. Oh, okay, this is the type of repair that they're gonna do, and they tell the contractor or they tell the engineer, "Hey, design this type of wall for this," and then no one's actually seen it. It's just like, all right, no one's actually seeing the design or back checking what the actual problem is, and there you go.
Yep.
And then you end up with one pier next.
Happens a lot.
Yeah, and I was thinking sometimes I've seen it actually. Somebody will put in a pier, say there's one post on a deck that's coming down due to settlement, so they'll come in, have a pier put in, and then the rest of the building's still on those spread foundations, so it keeps moving differently. And the salesperson will know that, but an engineer will pick up that kind of thing. So I think you're on the right track.
Right.
To just push everybody to an engineer, make sure all of the constraints of the project and the site are understood, and then you can come up with an effective repair or renovation. Yeah.
Well, I'll tell you one more problem that occurs. So if the homeowner calls the contractor, and the contractor comes out and starts work, and a lot of times the cities won't have city inspectors. They'll require a special inspector because it's kind of technical and it's not areas that their inspectors understand. So they tell the contractor, okay, well, supply your own special inspector, which, by the way, is against code, conflict of interest, right? Now you got a special inspector who gets hired by the contractor on every job. Is he going to rock the boat? No, he's going to let things go. But guess what? Halfway through the project, now the contractor says, hey, Mr. Homeowner, we need 15 more piers. There's a condition we didn't see when we were out here the first time, unknown condition, right? And the homeowner's like, I don't know. I'm not an expert. What's the special inspector going to say who's hired by the contractor? Hey, the contractor says he needs it. He probably needs it, right? That's not the right way of doing business. No, if the engineer is in charge and you have 3 bidders and you select a bidder, the responsible bidder, and now he comes back in the middle of the project and says, hey, we need to add 15 more piers, the engineer is going to say, dude, explain this to me, justify it. I don't see it. I know what's going on at the beginning of this project. And I mean, he could be right, but I mean, let's talk about it. I mean, the engineer's qualified to, evaluate that claim. The homeowner is not.
Did you have any, I know you've seen a lot of mistakes, but what are some of the top mistakes, if you could just add a little more to the mistakes that you've seen that maybe realtors or homeowners do when it comes to foundation repair?
Well, that's the big one, but I will tell you that the biggest mistake that I see happen in the industry is that people don't understand the difference between settlement and heave. So, you got one part of the house that's maybe getting a little lower, right? Differential settlement. Okay. But is it lower there, you're going to do a floor level survey, and it's relative because there's no benchmarks. So one part's lower, one part's higher. Did the lower part go down or did the higher part go up? Well, everybody just assumes it's the lower part went down. Well, that's not correct, because you get heave just as commonly in many parts of the country, maybe more common than settlement. And it could be that the high part went up, very common. And now you're going to underpin the low part. You're not even fixing the problem. You're not even addressing the problem, right? This happens constantly. And the reason it happens is because the foundation repair companies, they don't offer any solutions to solve that problem. The industry is divided up into suppliers and installers, and the installers get all of their understanding and learning from the suppliers. Well, the supplier educates the salesman. When you have cracks in the house, it means settlement, put in piers. They don't, the foundation, the supplier doesn't say anything about what to do if you have heave. Well, they don't have any products to offer for that. So heave go completely unaddressed.
Wow. Yeah. It's like misdiagnosis if we're talking about medical.
Yeah, exactly. Exactly. Misdiagnosis is the big key that happens a lot. This is why we need engineers to do this. And here's the problem. I can't get a lot of engineers. We're slowly starting to get some engineers that started to offer these services, but there's not a lot. And, and I keep thinking, hey, wait, aren't engineers supposed to be protecting the welfare of the public? Yeah, but we see this as a risky thing. It's not. Or we see this as not profitable. It can be. But engineers can have a profitable service with low risk and protect the public, which is sorely needed.
Yeah, and they would catch that kind of issue because if you do have eave and say one corner of your foundation looked like it dropped and you underpin that corner, or the helical piers or push piers, you can often use those to jack it back up to level, but now it's fixed in that spot. And if the part that heaved was to, lose the moisture that caused the heave and start to settle, well, now you're going to have a high corner and you're going to see the crack reopen due to that footing coming back down.
Or the heave will continue to go up, and you'll still have more distress, and you haven't addressed it at all. You've maybe re-leveled it a little bit, but you still haven't addressed the problem, and so then the problem continues unabated.
And it's easy because people see these types of underpinning systems go in all over, and maybe their neighbor had the same company come out and fix, and their house hasn't experienced any new issues, but it's only been a year. The weather's been pretty stable, so everybody in the neighborhood gets fixed in a 5-year period. Then all of a sudden things change 5 years down the road, and everybody's got problems again. So I think trying to understand the myth, I guess, the myths behind what these foundation systems can and can't do. What are the common myths that you are up against with your line of work?
Well, we talked about a bunch of them. Let me think if there's a couple that we haven't talked about. We've talked about the design donut hole. We've talked about lifetime warranties.
The one that stood out to me, because I've had issues in my own home recently that insurance didn't cover, was homeowners insurance covers foundations repairs. That's one of the myths.
I'm writing a blog on that right now. It should be out probably in a week or two. By the way, you can go to my blog, foundationrepairsecrets.com. I've got a bunch of blogs all on these subjects we've talked about today, and my book. You can find my book on there as well. Okay, so insurance. Most insurance, first of all, insurance is designed to cover sudden and catastrophic events that haven't been anticipated. If you've got foundation movement that's been occurring for 15 years, a little bit at a time, that doesn't really qualify as sudden and catastrophic, right? And the insurance companies have clarified that by putting in what they call an earth movement exclusion, which basically says if your house has issues as a result of soil movement, we don't cover it. Now, there are some exceptions to that. So let's suppose that you have a pipe break underneath the house and you have sudden movement and it's catastrophic, right? If you can prove that the movement is caused from that pipe break, you have a fighting chance of getting the insurance to cover it. Now, some insurance companies are better than others, right? But I've had a rental house and it was covered by insurance. They paid for the underpinning because I was called out a leak detector, and they showed 3 leaks under the house. And I had 2 engineers put seals on it that basically said, yep, it's from, this movement is from the pipe break, and insurance covered it. And I had a great insurance company. So that helped. But, let me just highlight an example. I had a huge commercial project up in the mountains, and it was a retaining wall, and they wanted me to hold the retaining wall while they dug below it for an addition. It's kind of a scary prospect, but we underpinned it and we put tiebacks on it. But during a big storm, while everything was still open and under construction, the whole thing collapsed 300 foot by 15 foot tall.
Wow.
And it almost endangered the 300,000 square foot clubhouse that it was next to. So, and my insurance company at first said, "Oh, we're not going to cover this because this is a soil movement problem." Here I have a multi-million-dollar claim, and my insurance company is telling me they're not going to cover it. I hired my own forensic engineer and I hired my own attorney because I didn't trust the engineers and attorneys from the insurance company. And it was a smart move because they proved that there was a big monsoon storm and water drained improperly inside the retaining wall that caused the problem. And then my insurance company had no choice but to cover it because it was a water caused problem, not a soil caused problem.
And so that kind of actually ties into the other myth I wanted to hear about, because that's a case where you hired an engineer to prove, against the insurance company. But I think oftentimes you could hire an engineer to basically put you at ease without getting anything done. And one of the myths you had listed was all cracks in a home indicate that a foundation repair is needed. I think hiring an engineer would help you with that.
I mean, it's absolutely not true. I mean, I hear salesmen say things like, "Yeah, on a scale of 1 to 10, I think it's like an 8.5, Mr. Jones,
I'm in a danger.
What scale is that? Is that like the BS scale? I mean, you can measure tilt, and the industry standard says you get more than 1% tilt, or you have deflection, L over 360, right? Deflection, you get more deflection than that, then that's not acceptable. And those are serviceability things. Those are not structural things most of the time. But at least it gives us an objective standard, right? Foundation repair companies don't even know what those are. I mean, if you ask them, they give you deer in the headlights look, right? They just like, this is why you need engineers here. They're going to be objective. They're going to follow standards. They're going to do things the right way.
Yeah, Bob, how do you recommend engineers get more involved? Like, how could they work with the homeowners, realtors, everyone, contractors even, to make their presence more known, or like they seem to be out of the picture most of the time when the contractors or the salesmen are involved?
Yeah, right. Well, I mean, I have a directory for forensic engineers on my website, and it's free. People can get on there. I don't charge anything. I'm just trying. I get a lot of calls from homeowners that say, "Hey, I'm in Wisconsin and I don't know any forensic engineers. Can you help me out?" And so after like doing that a gazillion times, I finally just like bit the bullet and made this list. I've vetted most of these guys, but at least I went onto their website and found out that they do residential forensics, right? So it's a start. But if somebody wants to do this, a good place to start is just get on my website. I get a fair amount of visitors on there, and it's just all about trying to help the homeowner. Trying to take care of them and make sure that they don't get ripped off. Basically, is what it amounts to. And but I've helped a lot of engineers with their marketing. I'm pretty good at it. I did it for a lot of years, and I kind of know the ins and outs and how to help them, right? Yeah, it takes a bit of effort. You got to specialize in it. Most engineers don't do forensics, right? Most engineers do new design or remodeling, or, most of them work in, infrastructure. And they don't even work in residential. So it is kind of a niche area, but I think it's a sorely needed niche. And I think it can be, it's basically unaddressed in most parts of the country, and can be a good one. I mean, your website.
Yeah, we'll definitely link to your website.
Yeah. I mean, you need to have a forensic website that, explains what you're doing, right? So the Google spiders can crawl across your copy in your words in your website, and hopefully those are words that people are searching for, right? And they make sense, and they're helpful, and they give value to people that read them. And when that happens, then they become more used and more relevant in Google's eyes, and now you go up in the recommendation chain.
Yeah, I think that's something that a lot of engineers don't know about. And like you were mentioning, residential for those types of projects, yeah, you do have the homeowner just Googling. You don't have those huge multi-million-dollar projects where they already have a team assembled. It's no, you just have a homeowner just not very aware,
Right.
and you can help them out by advertising your services properly to help protect them from everything else.
Right. There's cheap ways to advertise too. I mean, you don't have to blow the budget, right? I mean, there's lots of good ways to help yourself. It, and I've helped a lot of engineers with that. I don't even charge.
That'd be very helpful for quite a few firms out there, I imagine. All right, I think we're to the point where I can ask this: what final piece of advice can you give to structural engineers who want to keep their clients and avoid common pitfalls while delivering successful renovation projects?
Well, in this particular case, probably not going to be a lot of repeat clients, right? I mean, if you do it right, hopefully, right? So the idea is to carve out a good reputation for yourself for taking care of the issues and taking care of people, right? And if you really do take care of people, then you're going to get a reputation for taking care of people, and that counts, right? Your reputation is all about what it's about as an engineer, and if you have a better story to tell, if you have a better rationale, eventually, if it's true and it's real, Google and the marketplace will reward you for it.
Yeah, it's as the engineer, you have the ability, you have the knowledge to clearly explain all these problems with that to the homeowner that the contractor probably won't have, because the technical knowledge isn't there, the engineering isn't there. So it's something that the most engineers already have.
You're right. From a technical point of view, that's correct. But the engineers have a disadvantage, and that is that it's called the Dunning-Kruger syndrome. The bigger your mouth, the less you know. And these sales guys, they're very, they get paid very well. They project very well. They're very confident. Engineers are going to talk in probabilities. They're not going to be, real convincing like. So they've got to find ways to communicate convincing. Maybe that, helps homeowners understand that they know what they're doing. Because you got the foundation sales guys that are saying, "Oh, I've been doing this for 30 years. I'm smarter than engineers. I've been out here in the trenches. I've seen what works. I've seen what doesn't work." Engineers don't do that. They sit up in their ivory tower and they don't have a clue. And you've got to be able to counter that narrative, which can be done, by the way.
Yeah, seems like that's another skill where, yeah, you don't want to scare the homeowners with all the technical jargon. Then they still won't know what you're talking about. They're just going to go to the contractor because they sound more competent.
Visuals help a lot. Visuals help because these concepts are unknown to homeowners. Half the time, they don't even know what a footing is, So visuals help. It's one of the big clues I can give here is that visuals help a lot.
Have you seen any good partnerships between, say, a structural engineering firm and a foundation repair contractor that kind of closes the gap on all this? Not like every team out there is doing it wrong. There's going to be somebody doing it right.
There are a few doing it right, not very many. And you know, and it's my job to promote that. Hopefully we'll get more, right? But most of the partnerships that I see between foundation repair companies and engineers are where engineers just help on the back end. They do the spacing calc. You know, that's not really helping the homeowner. Honestly, it's not. Hate to break the bad news, guys. You got to do the engineering on the front end, and you need to be the one in charge, not the foundation repair contractor. Now, if the foundation repair or if the engineer rather gets a good reputation and people start calling him a lot, guess what? Guess who's going to be knocking on their door wanting to get a few projects? The foundation repair companies, and then you can build a good relationship that way, right? But that's the way it ought to be done. Unfortunately, it's the other way around right now.
Yeah, that makes sense. Yeah, a lot of them just maybe just want the stamp of the engineer. I mean, that's why you get the back end.
Yeah. And part of the problem is the jurisdictions don't know. The jurisdiction should be requiring that the seal, the engineer's seal, identify the problem and identify solutions for the problem. They're not.
Yeah.
All they're requiring is a space calculation. You know, so that's one of my missions, is to try to get jurisdictions to change that requirement.
Yeah. Yeah. Thanks so much, Bob. I appreciate this. I think everyone's learned a lot about some of these things and even how the industry works a little bit, something that I haven't really been involved in the residential area. So yeah, thanks so much for all these tips and insights. And
I'm glad to be here.
Yeah,
absolutely.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, or questions. To leave them, please visit the structuralengineeringchannel.com. There you'll find a summary of key points discussed in today's episode, as well as the links to any of the resources or websites mentioned during the episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. And until next time, we wish you the best in all your structural engineering endeavors.